Good morning, students. I am Dr. K. Vishnuvardhan Rao. So today, I will introduce a new subject. Name is called Water Resource Engineering 1. In this topic, I will introduce the subject is Water Resource Engineering 1. The topic is engineering hydrology and its applications, hydrological cycle, hydrological data sources of data. These topics we will discuss clearly in our today classes. Before going to this, I want to introduce the history of the water resource engineering throughout the world and in India. Here, what is engineering hydrology? First, we have to see definition. The definition is engineering hydrology is the science of water resource engineering, which it deals with the study of occurrence, distribution, movement, and the properties of water on the earth or beneath the earth's surface or in the atmosphere. So simply, what is engineering hydrology? Engineering hydrology deals like the occurrence of the water, where it was occur, and how it was the distribution, and how it was the movement underneath the earth, and the properties of water on the earth or beneath. Beneath means here we have to call as a groundwater. So beneath the earth surface or in the atmosphere, whether it is in the earth surface or atmosphere, where it will happen. These all things discussed clearly in engineering hydrology. Now, the engineering hydrology deals with the following features. What is the features of engineering hydrology? Just here, three categories is there. The first one is estimation of water resources. The second one is study the components of the hydrological cycle like precipitation, runoff, transpiration, and their interactions. The third one is study the problems of floods and droughts and preventive actions. Here, the scope of engineering hydrology. The scope of engineering hydrology is four subcategories here. The first one is determination of maximum probable flood, determination of water yield from a basin, study the groundwater development, determination of maximum intensity of the stroke. Here these are all main aspects from the engineering hydrology. Here the determination of maximum probable flood means if a civil engineer construct a dam, first he need to calculate the probable of the maximum intensity of the flood. So that's why he need to determination of the maximum probable of flood. Next, determination of water yield from a basin. Basin means actually a river, it has some plenty of water, but some basin has produced a lot of water to the this river. So that's why we need to calculate what is the yield of the basin. Next, to study the groundwater development, and the fourth one is the determination of maximum intensity of the stroke. So due to this, we have to estimate the maximum intensity of storm. That is, depending on that, we can calculate the intensity of storm, and we can make a decision on the height of the dam or reservoir something. Here, the determination of maximum probable flood. The study of hydrology can help in determining the maximum probable flood that can occur at a particular location. It is frequently is also determined that is essential for the design of hydraulic structures like dams and reservoirs, channels, and other flood control structures. Determination of water yield from a basin. For the design of dams and municipal water supply units, river navigation, it is necessary to determine the occurrence, the frequency, and the quantity of water that can be yielded from a basin. This is performed in hydrology. Next, study the groundwater development. The knowledge on hydrogeology of the area helps to understand the groundwater development that influences the recharge facilities like reservoirs and streams, climate, cropping pattern, these all things. So here the study the groundwater development I want to share my experience when I was work as a hydrogeologist in Prakasam district, Kambam area. In that area, actually, just we selected 222 hydrological wells, and for every 15 days, we calculated the SWL. SWL means static water level, and PWL post water level. And when water was running, the after 1 hour or 2 hours, we collected the water from the borehole. So that can be, we have to call as a discharge. So these all things involved in the part of the groundwater development. Next, determination of maximum intensity of storm. The maximum intensity of storms influences the design of drainage projects which are studied in hydrology in depth. Here, okay, the above things is just the above things will give a small picture to what is hydrology or what is the engineering hydrology. Here, applications of engineering hydrology. Hydrology provides guidance for undergoing proper planning and management of water resources, calculates the rainfall, surface runoff, and precipitation. It determines the water balance for a particular region. It mitigates and predicts flood, landslide, and drought risk in the region. It estimates the water resource potential of the river basins, enables real-time flood forecasting and flood warning. Hydrology analysis the variations observed in the catchments by bringing a relationship between the surface water and groundwater resources of the catchment. Hydrology studies the required reservoir capacity that is necessary for irrigation and municipal water supply purpose during drought conditions. It is used in the design and operation of hydraulic structures. It is used for hydropower generation. Brings measures to control erosion and sediments. Now, what is hydrology? Hydrology and the hydrological cycle are important science that deals with the depletion and the replacement of the water resources. The knowledge of hydrology is necessary to perform design, operation, and maintenance of the water resource engineering projects. But as a civil engineer, must have the basic knowledge of hydrology to engage in the design, planning, and the construction of several irrigation structures, flood control works, and bridges and highway culverts. But what is the hydrological cycle? Hydrological cycle can be defined as the continuous process of exchange of water from the Earth's surface to the atmosphere or vice versa by the influence of solar radiation or solar heat. It is a closed system where the water gets transformed either from one place to another or from one from to another under the action of sun heat. Whatever be the process, the total water in the whole system remains constant. The representation of the hydrological cycle is represented. The hydrological cycle is involved in the total earth system. The total system can be classified into three important zones: atmosphere, hydrosphere, and sorry, and lithosphere. Atmosphere forms the gaseous envelope that is above the hydrosphere. Hydrosphere forms the body of water that is uh, covering the surface of the earth. The environment that is below the hydrosphere till a solid rock forms the lithosphere. Excuse me, guys. Okay. So sorry for interruption. So hydrosphere forms the body of water that is covering the surface of the earth. The environment that is below the hydrosphere till the solid rock forms the lithosphere. Actually, these all things we studied in our lower classes, but here just I want to repeat your knowledge. Now, this figure is a give clear picture to what is hydrological cycle. Here, just I will explain step by step. First, due to the sun radiation or sun heat, the water from the seas or rivers, lakes, ponds, whatever it may be, where water available on surface of the earth, including oceans, due to the sun energy or radiation or heat, that all type of the water evaporated takes place. And when the dust particles in the atmosphere available, these water vapor settle on the dust particles and they form as a cloud. Due to the differences between the wind velocities, the clouds moves up and down. And when here just from the figure, the evaporation takes place and it changes into the clouds, and then clouds are passing past. And when the clouds taking the cool air from the atmosphere, automatically it will take the condensation. When it will take condensation, some rain or snow or hail, some part of the clouds, it will reach on the surface of that as in the form of the precipitation. So due to this one, the cloud has a lighter, so then it's going to the up and move to higher areas. Here from the runoff has taken, evaporation takes place in melting and melt runoff, and in some areas these precipitation reaches on surface of the earth as a ice or a hail. So, and due to some geological formations where water takes the runoff from the lakes or rivers, that water, some of the water from the main water is infiltrate or percolation to the groundwater due to some favorable layers. So here infiltration, and that infiltration water reaches the groundwater or ground surface, that is called a groundwater flow, and groundwater discharge, infiltration, storage as groundwater. So from the figure we can understand the how hydrological cycle or water cycle involved in our atmosphere. Now, what are the basic components of hydrological cycle? The basic components of hydrological cycle constitute, here I wrote here. The first one is the precipitation, runoff, evaporation, condensation, transpiration, evapotranspiration, infiltration, depression storage, and interception. These all are the process involved in the hydrological cycle. Here we can clearly discuss step by step. Now we are coming into the precipitation. What is the precipitation? It is the fall of moisture from the atmosphere to the earth's surface in any form. Example, rain, hail, snow, sleet, glaze, drizzle, or snowflakes. These are all the examples of the precipitation. Now runoff. Runoff means it is the water flowing over the land, making its way towards rivers, lakes, oceans, as surface or subsurface flow. And here again runoff takes place with two types: surface flow and subsurface flow. Surface runoff means it is the running water over the land and which ultimately discharge water to the sea. The second one is the subsurface runoff, the water getting infiltrated into previous soil mass, making its way towards the rivers and the lakes, can be termed as subsurface runoff. Evaporation. It is the conversion of natural liquids like water into gaseous from like air. Evaporation happens in the water bodies. Next, condensation. Condensation is nothing but a cooling. It is the conversion of a vapor or gas to a liquid. The water vapor evaporates from the water bodies like ocean, sea and river. These vapors, after reaching a height around 20 kilometers in the sky, undergo condensation and forms clouds. These later precipitates as rain, fog, fog, and transpiration. It is the evaporation taking place from any plant or greenery. For example, a water droplet on a leaf getting evaporated into the atmosphere. Evapotranspiration. It is the combination of evaporation and transpiration. Infiltration. It is the process of filtration of water to the inner layers of soil based on its structure and nature. Previous soils go through more infiltration than impervious. Infiltration in soils like sand, gravel, and coarser material is more, and for finer soil particles like clay and silt, infiltration is less. Infiltration is inversely proportional to runoff. In soil, if infiltration is less, then the runoff is more. Similarly, more infiltration gives less runoff. Example, bitumen roads have more runoff than metallic mud roads. Next, depression storage. It is the part of precipitation required to fill depletion zones of land. Interception. Part of precipitation required to wet the surface of soil, buildings and all previous surfaces is called interception. Now, process of hydrological cycle. The process of the hydrological cycle starts with oceans. Water in oceans gets evaporated due to heat energy provided by solar radiation and forms water vapor. This water vapor moves upwards to higher altitude forming clouds. Most of the clouds condense and precipitate in any form like rain, hail, snow, sleet, and a part of clouds is driven to land by winds. Even during the process of precipitation, some parts of water molecules may evaporate back to the atmosphere. The portion of water that reaches the ground enters the earth surface infiltrating various strata of soil. This process enhances the moisture content as well as the water table. Vegetation sends a portion of water from the earth's surface back to the atmosphere through the process of transpiration. Once water percolates and infiltrates the earth's surface, runoff is formed over the land, flowing through the contours of land heading towards the river and lakes and finally joins into oceans after many years. Some amount of water is retained as a depression storage. Here I want to give you an example. When I was on research in Andhra University, we identified some deltaic water and in subsurface earth. We calculated the age of the water. Actually, that water age is really being mesmerized. The age of water is 25,000 years back. Now, further again, the process of this hydrological cycle continues by blowing of cool air over the ocean, carrying water molecules, forming into water vapor, then clouds getting condensed and precipitates as rainfall. Similarly, the water percolates into the soil, thus increasing the water table and also the formation of runoff waters heading towards water bodies. Thus, the cycle process continues. And here, water balance equation. As per the water balance equation, the sum of inflow waters is equal to sum of the outflow waters. Out of the three process, precipitation, runoff and evaporation, inflow is precipitation. Runoff and evaporation comes under outflow. Then the water balance equation can be written as precipitation minus runoff is equal to evaporation. That gives precipitation is equal to evaporation plus runoff. This equation is the most important for hydrological modelings. Now, the hydrological data and the sources of data. Already previously we discussed clearly what are the hydrological data, but here we mentioned the sources of data. What is the sources of data? Collecting the hydrological data. Weather and climate records is one of the source of the data. Precipitation data is a source of data. Stream flow data is a source of data. Evaporation and transpiration data also useful. Infiltration characteristics of the area is the one of the source of the data. Groundwater characteristics, physical and geological characteristics also sources of the data for hydrological data. Now, weather and climate records. Data about temperature, humidity, radiation, wind, since these directly affect hydrological parameters. Here also I want to give my real experience when I was working as a hydrogeologist. In my research area, we established some temperatures. So using day temperature and night temperature, we calculated humidity. When we get the humidity more than 90% in the atmosphere, from pinpoint of that area to within surrounding of 50 kilometers, definitely rain will happen. So that is the one most important climate parameter of the humidity. Next, radiation and wind. Wind also very important to calculate the wind speed. Okay, next, since these directly affect hydrological parameters. Next, precipitation data. The study of precipitation forms a major portion of the subject to hydrometeorology. The precipitation data helps in predicting runoff volume and its peak. It is also helpful in estimating the water budget equation for the basin. It gives indication to the further potential for expansion of water needs and plan accordingly. Next, stream flow data. This helps in the planning of reservoirs, design of spillways, bridges, culverts, levies, and water power development and installation. The data is utilized for determination of maximum flood, flood magnitude, flood frequency, reservoir elevations, water budgets. These are the examples of the stream flow data. Next, evaporation and transpiration data. This data is required for determining water budget for the river basin, reservoir capacity for water resources, development and evaporation suppression techniques, infiltration characteristics of the area. This data helps in the determining rainfall excess and runoff computation, groundwater characteristics. This helps in estimation and location of groundwater reservoir for groundwater development, physical and geological characteristics. This helps in the determination of runoff pattern and the silt load movement. Indian Meteorological Department IMD is largely responsible for the collection of the meteorological data throughout the India, along with some state government agencies. The Central Water Commission (CWC) monitors the stream flow data for major rivers. Here, these are the uh, these are the so in our class we discussed clearly what is hydrology, engineering hydrology, and applications of engineering hydrology, and what is the hydrological cycle and how it affects the atmosphere, and the hydrological data and the sources of the hydrological data, and the what is the main source of hydrological data. These all we discussed in our class. Now here just I want to show a video, the what we discussed in our class, those all things combined and make it a video that I will show to you now. Okay, guys, and we will meet in our next class. I will explain next topic in our next class. Thank you.